Linear regression predicts unlimited values, even negative numbers. But when we ask is this spam, we need probability between 0 and 1. We can't return negative predictions or outputs greater than 1. We need a mathematical function that squashes infinite values into this bounded range. Enter Sigmoid. Sigmoid is mathematically elegant. Its formula, 1 divided by 1 plus e to the negative z. No matter what you feed it, negative infinity, positive infinity, anything out comes a probability between 0 and 1. Negative inputs approach 0. Positive inputs approach 1. 0 maps to exactly 0.5. It's the perfect S-shaped bridge for mapping scores to probabilities. Here's the critical insight: at 0.5, we draw the decision boundary. Above 0.5 means predict spam. Below 0.5 means predict legitimate. The sigmoid function creates this threshold automatically. The model learns to assign feature weights so spam emails score high and legitimate emails score low. This creates a smooth, probabilistic boundary rather than a hard cut. A probability of 0.8 means 80% confidence, spam. A probability of 0.3 means 30% spam confidence or 70% legitimate confidence. At 0.5, maximum uncertainty. This is sigmoid's brilliance: you get confidence scores, not binary labels. Real-world systems use these scores to adjust sensitivity. Strict filtering requires 0.9 confidence. Loose filtering accepts 0.6 confidence. Probability empowers control.